All right, good morning. So what are we learning today? Today, we are learning, our standard is that you could write a quadratic given the zeros, and then you could find the exact quadratic given the vertex. So there's quite a few things to understand here. It's how to go from zeros to what's called linear factors, and then how to go from linear factors back to the quadratic. Okay, hopefully you've already done the bell work, which was ACT, and we'll go ahead and get started. So I have some pictures of some graphs here. In the first couple pages, it is review to start off. So I have three functions. So I have the f function, the g function, and the h function. And so the question is, list the zeros. Here, I'll even highlight that for us. So we're supposed to list the zeros. So what does it mean to be a zero? A zero is where it crosses the x-axis. So I have a zero here, and I have a zero here. After further investigation, I think that is -1, 2, 3, -3, and 1. Okay. Now the zeros here looks to be -2 and 1, 2, 3, 4, 5, -2 and 5. And then finally, here, they're both negative zeros. Looks like -1 and -4. So we could find the zeros. If someone were to ask me, how many solutions does this have? I would say 2 real solutions, 2 real solutions, 2 real solutions. They're both distinct. They're both different. And here we have a negative and a positive solution. Here we have a negative and a positive solution. And then these both are negative. Now remember, if this was like shifted up and it never crossed the x-axis, we call those solutions imaginary. Okay. So we're going to be using what's called the zero product property. And we've already talked about this property. And it basically says if you multiply two numbers and you get 0, then that means one of those numbers was 0. So for example, if I multiply these two numbers, x plus 1 times x minus 3, and I get 0, then by the zero product property, that means x plus 1 equals 0, or x minus 3 equals 0. So the zero product property really helps us solve and find the solutions. Now this is a product because when you have something in parentheses times something in parentheses, that is a product. So this means x plus 1 times x plus 3. Solving these, I would subtract 1 from both sides. I get x is -1. So I know on this one, the x-intercept is -1. And then here I would add 3. And I get x is 3. Okay, so we have something called linear factors. And so what does it mean to be a linear factor? A factor usually is written like x plus 1, 2x minus 3. And we call those linear because those are x to the first, x to the first. So I would say linear factors are, I don't really like using one of the words in the definition, but factor should be a common word, you know, but a factor, I'm about to put factors that are linear, but factors that are, I'll say first degree. what that means is x to the 1. But basically, they're lines, okay? They're in linear form. So let's go out to Desmos. And again, a lot of this is review on purpose. And we're going to type that into Desmos, and we're going to list the zeros. We already know the zeros. We already know the zeros are going to be -1 and 3. So these are what we call linear factors. X plus 1 is a linear factor. X minus 3 is a linear factor. And then what would the zeros be? The zeros would be -1 and 3. So let me go type that in. X plus 1, X minus 3. X plus 1, X minus 3. And looky there, for X plus 1, the solution is -1. For X minus 3, the solution is 3. Okay, so this is what we call intercept form. It tells us the x-intercepts. These are also called solutions. They're also called roots, and they are also called zeros. So what are the zeros? -1 and 3. We just found those. Okay. So k of x is a quadratic written in standard form. And when you write something in factored form, when you write something in factored form, you're going to have your linear factors, and you're going to have this a value out here that, remember, the a value stretches it or compresses it. Another way to say compress is widen. And so the first 3 functions we did, the a value is 1. And we're going to talk about how to find that exact a value. So for example, notice they tell us the a value is 1. So we're gonna do this with a value equals 1, and then I'm going to show you how to find the a value when it's not 1. So looking at our functions, and I'm going to need this paper back, f of x, so this was f of x. The zeros were -3 and 1, right? And so the linear factors would be x plus 3, x minus 1. And normally you need to find this a value. You need to find how much is it stretched or compressed, because that moves around the vertex too. But they told us the a value is 1, so I'll just put 1 here. But normally you need to find that. And again, how do I know the a value is 1? They told me. Okay, so you need to put it in this form. How is this stretched or compressed? Is it flipped over? Remember, if you change this to negative, it flips it over. And then you just put your linear factors there. So let's go and do g of x. G of x, so here's g of x. We said x-intercepts are -2 and 5. So the linear factor for -2 would be x plus 2. And the linear factor for 5 would be x minus 5. So I'll go over here and put x plus 2, x minus 5. And again, they told me that the a value is 1. So I don't have to find it yet. Now let's go do h of x. H of x had solutions -1 and -4. So what we call linear factors would be x plus 1, x plus 4. So I'll go to my h of x and I'll put h plus 1, or x plus 1, x plus 4. And they told us the a value is 1. Okay. So these are the very simple ones when they tell you the a value. If they don't tell you the a value, I would at least put an a there. You cannot just tell someone the zeros and expect them to find the equation unless they give you more information. So now let's go and confirm this. Okay, so I'm going to go type this in Desmos and make sure it matches f of x. I'm going to make sure this matches g of x. I'm going to make sure this matches h of x. So that's going to take me just 1 second. All right, f of x was 1, x plus 3, x minus 1. And notice, this is going to take a lot of work switching back and forth. How do I check my work? Notice the solutions are 1 and negative 3, and the vertex is negative 1, negative 4. So let's go look and see what the graph looked like. Notice the solutions are the same. And I said the vertex was negative 1, negative 4. Yes, it is. Okay. Now, let's go confirm this one. All right, so let's go plug G in. And I already know that my graph is going to look different because this one's upside down. So let's go and see what G of X is. So I'm going to go plug this into Desmos. And that's 1, x plus 2, x minus 5. So notice the solutions are 5 and negative 2, which is what I wanted. However, it's facing the wrong way. So they lied to me. They said A has a value of 1. That is not true. I need this to flip over. So I need to put negative there. And there it is flipped over. Looking at my graph here, my vertex is 1.5, 12.25. So if I go look at my graph, because I already know the solutions are negative 1 and 5, but I need to check out this vertex, see if it's 1.5, 12.25. Let's see. Yeah, it's about 1.5, 12.25. Okay. So looking at this, I'm glad I flipped it over. So in order to flip it over, and I apologize, the note said A has a value of 1. They lied to us. We need to flip this one over. And then finally, let's see if x plus 1, x plus 4 matches this graph. This one has a vertex of like negative 2.5, comma negative 2 approximately. Let's go see. So h of x is 1, x plus 1, x plus 4. Notice the vertex is negative 2.5, negative 2.25. And I don't know what you guys can see, but it is the same thing, approximately. Okay. So what happens, and this is the lesson for today, how do we know what that A value is? Because watch this, as I see the vertex right here is negative 2.5, negative 2.25. If I keep the solutions the same, but I change this number, notice it changes the vertex, but it does not change the solutions. The solutions will always be negative 1 and negative 4. But as I change this, notice it changes my vertex. So as I make this number bigger, it stretches it. And as it stretches, the vertex kind of falls down. So You know, I could make it even not appear on the page if I wanted. I wanted the super skinny. Maybe I'd put in like 100. See, now the vertex is, wow, way down here. I mean, I already lost track of the vertex. Where did it go? Okay, maybe we won't do 100, like 10. So here it got super skinny. And then remember, if I want to flip it over, then I just put a negative out front, flipped over. We call that a reflection over the x-axis. And then if I want to make this wider, then I need to, and we did this in transformations, you do a fraction between 0 and 1. So you can do 1/2. That makes it fatter. Notice the vertex changed. I could do 1/3, 1/4, 1/5, 1/6, 1/7, 1/8. Notice it's getting wider and wider. Some people use the word compressed. So the skill for today, finally, is if someone tells you the solutions and they tell you at least the vertex or any other point, can you write the quadratic? And we could just leave it at factored form for now. Okay, so that is the skill for today. This won't take very long. Back to our notes. I have some new functions. I have the B function, looks like this. I have the K function, it looks like this. And this is the R function. Now, most students, the functions confuse them. You can see why we name them different letters, the R function, the K function, the B function, so that when I say, hey, tell me about the K function, you're looking at this graph. If they were all y equals, it would get confusing. Like which one? So let's start off with the B function. What are the zeros? Well, the zeros look to be 1 and -3. So then what are the linear factors? Well, the linear factors, what number, or I'm sorry, x plus 3 for -3. And then we have x minus 1 for 1. And then what is the vertex? Looks to be -1. And then how far down? Looks to be exactly -4. So -1, -4. Okay. Now let's go do the K function. So K is in the middle. It looks like the zeros are -3. And is that 1? Ah, the same zeros. That's kind of nice. But they have the same zeros, but this one is skinnier. Okay, so they cannot have the same a value, but the linear factors are going to be the same. It's going to be x plus 3 also, and x minus 1. So looking at these pictures, I could tell you that this a value is going to be bigger than this, but they're going to have the same linear factors because the vertex looks to be -1. Oh, I can't. Is that -8? -1, -8? Okay. And then finally, we're going to go do the R function, which it looks to be -3 as the solution. And the other solution looks to be 1. Wow. Same solution again. Same linear factors. But this one appears to be wider. So in order to be wider, this is going to have an a value between 0 and 1 probably. And looking at the vertex is -1, -2. So if someone said, what is the equation? And you put x plus 3x minus 1, well, you're going to be wrong because you can see they all have the same linear factors, but they all look different. So how do you find the a value? And that is today's lesson, finally. Okay. So what is similar about these? They all have the same zeros. What's different? They look different. They have, some are more stretched, some are more compressed, and they all have different vertices. Vertices, I should say. So the factored form of a quadratic is y is the number that tells me of how much stretched or compressed it is times the linear factors. So using the vertex and two linear factors that you discovered, find the a value. Okay, so what I have for b, and I'll copy down, b we said was, I'll write down what we had. We had x plus 3, and actually I'll write it like this. We'll say y is, and we don't know how much it's stretched or compressed, but it was x plus 3 and it was x minus 1. And then k was also, I mean, they're all the same thing. We don't know how much it was stretched or compressed, but it was x plus 3, x minus 1. And then r was the same thing. We need to know how much it was stretched or compressed, but we know the solutions were -3 and +1. So how are we going to find that a value? We need one more piece of information. And the piece of information I'm going to pull out is the vertex. So remember, the vertex for B was -1, -4. The vertex for K was -1, -8. And the vertex for R was -1, -2. So I am going to go copy down the vertices. So the vertex on this one, we said was -1, -4. The vertex on K was -1, -8. And the vertex on R was -1, -2. So what that means is we know a point on the parabola. We could use this point on the parabola. We know this is my x. We know this is my y. Looky there, I have an x, I have a y, and I could use that to find my y value. So in an equation, when you have one equation, you can find any value you need if you know every other value but the one you need. So I'm going to plug in the y, which is -4. And then I'm going to plug in x is -1 into here. And then I'm going to do the math and find the a value. Okay. And I will say, I hope it's okay, this is on the test. So make sure you pay attention here. So again, this is the y value. So I'll put -4 equals a. I don't know what a is. I'm trying to find the a. But I do know the x value. The x is -1. So I'll put -1 plus 3, -1 minus 1. And then I'll solve for a. -1 plus 3 is 2. -1 minus 1 is -2. And then 2 times -2 is -4. So I have -4 equals -4a. All I did was put 2 times -2 in front of a. And then I'll divide both sides by -4. And -4 divided by -4 is 1. So I say a is 1. So now when I write my equation, I know, and I'm going to be more specific this time. I'm going to write it instead of y, I'm going to put b of x. You could put y if you want. I'm using b because that was the b function. B of x equals 1 times x plus 3 times x minus 1. All right. Next, let's go and do the same thing. So I am going to, again, and I'll color code this a little better. I am going to put this x in for this x, because that is x. And I am going to put -8 in for y, which leaves just a, and then I could solve for a. So y is -8. Maybe I shouldn't use highlighter. X is -1, so it'll be -1 plus 3. And then x is still -1, so it'll be -1 minus 1. And that's going to be -8 is a. And then, I mean, we could keep doing this, but we already did it earlier. We said this is, I'll just show it. -1 plus 3 is 2. -1 minus 1 is -2. So you still get -4. But now when you divide by -4, because this number got a little bit different, divide both sides by -4, and you get a is 2. So when I plug in and I tell someone the equation, since it's k of x, or you could put y, I'm going to say k of x is 2. K of x is 2x plus 3, x minus 1. By the way, if they don't tell you a piece of information for the like a point or vertex, then just leave it as an A. Okay. All right, one more. Again, I'm going to take my x value that they give me or that I saw. I'm going to plug it in to x. And I'm going to plug this one in for y. So I get -2 equals, we're trying to find the a, and then I'm tempted just to put this as -4 because I already know this is going to make -4 with the same zeros, but I'll show the work. -1 plus 3, -1 minus 1, -2 equals a times 2, and that's again -2. So 2 times -2 is -4. Divide both sides by -4. And -2 divided by -4, the negatives cancel. 2/4 is 1/2, so I get a is 1/2. Which is good news because remember I said that it was going to be fatter, it was going to be wider, it was going to be compressed. To be compressed, we need that a value between 0 and 1. So then I'd have r of x is 1/2 x plus 3 x minus 1. So these are these are in what we call factored form. If they wanted you to write this in, say, standard form, you would just distribute everything out. You could distribute everything out, but I'm okay with factored form. One last thing, and then we'll be done. We're going to just plug all of these in and just confirm real fast. So we said the first one, b of x, was 1, x plus 3, x minus 1. And just to save time, we said in our notes the vertex was going to be -1, -4. Let's go look. -1, -4. The next one we changed, and I'll type it in a new equation. We said this is 2, x plus 3, x minus 1. And we said the vertex should be -1, -8. There we go. It is -1, -8. But notice they have the same x-intercepts. And then the third one we said was 1/2 x plus 3, x minus 1. Notice it has the same x-intercepts. Looking at my graph, we said in our notes the vertex should be -1, -2. And the vertex is not -1, -2. What did we do there? I got -1, -8. Huh. Oh, someone chatted for me. Hopefully it's the, you are looking at the wrong one, I think. Oh. Ah, yes, I was. Yeah, it gets confusing with all those graphs. Thank you. There it is. It's like, I know I taught that right. Yeah, there it is. So there it is. And we said the vertex should be -1, -2. And there we are, -1, -2. So I'll leave you with this. Notice that all of these graphs have all the same x-intercepts, just some are stretched or compressed more than others. Now, what does your practice look like? And then we'll be done. Give me like 2 more minutes, if that. Wow, see? So we have all these functions. We have the A function, B function, C function, so on. Some are flipped over, some are not. But notice they all have the same x-intercept, but they all have different vertices. And so in your practice, for each function A through E, write the quadratic equation in factored form that is graphed. Okay. So I highly encourage that you check your answer on Desmos and don't get confused like I did looking at the wrong one. So you could, when you're done, type it all in and just make sure you have the same picture. But that's all I have for today. Sorry I took a couple extra minutes. I'm about to sign in office hours. Have a nice day.